This slide is very important for the students and all faculties of the scholars. So when they are entering into the industry, pharmaceutical industry, actually before starting, actually I forgot the one words. The now in the trained current scenario, statistics is the most vital in the pharmaceutical quality. So without statistician, pharmaceutical sector is useless. Okay, so uh, you have to also to be statistician through the learning or sharing the knowledge. Fine. So creating the control chart. How to create the control chart? Very important and just minutely you observe. First, the steps how to involve. First, the calculation of the process standard deviation. Already, I have shown the before slides. What is the process means? What is the standard deviation? What is the sigma level? Now, create executions of that sigma level in the pharmaceutical sector to maintain the process quality. First, the calculation of the process standard deviation. Next, the setting of the control limits, upper control limits and the lower control limits. And third is the creating control check. And one thing is that specification limit describes in the monograph. Okay, all Indian pharmacopoeia, British pharmacopoeia. So you will get the specification need of any your products. But you have to create the control limit and lower control limit through control charts. See, standard deviation, is one of the most common and widely used variability, a measure of the variability of the characteristic, the set of observation by the average range divided by the constant. This constant, this constant statistically is the unit, right? Already mentioned in the statistical books, and you have to calculate through this formula, standard deviations. Okay, average range divided by the constant that depends on the sample size. Understood? Next, calculation of the process standard deviation. So you have to calculate the process standard deviation. You have to the moving average method. So what is the moving average method? See, next slide. So moving average method is the difference between the two successive observations. Okay, to estimate the process variability. See, next slide, you can understand what is the moving range. See, suppose I'm giving you the one example, the paracetamol. How to estimate the standard deviation? See, this is the number of population, one sample. So I'm taking 1 to 10 samples. Understood? And here this contains, as per the pharmacopoeia, as per the test, our test specification already through the quality control, in the first sample, the content of the paracetamol in the 505.15 mg, right? In case of the second sample, we observe 505.66 milligram quantity, paracetamol quantity. In such a way, already 10 samples taken, and we already calculated or measured through the quality control the different paracetamol quantity, right? Moving range, in case, so this difference 505.66 minus 505.15. This is the moving range. You start moving range from the second population. In such a fashion, you calculate this moving range. I already told these calculations, a control chart, you never finding in the any statistical book. I just sharing very typical and very important slides. So moving range are the calculated using the formula, already given the formula, difference between second to first. Average of data. Here you already calculated. So from this 10th populations, you measure the average from this data, right? And moving range average, from here you easily calculate, right? So now sigma, standard deviation we measure. Already I told standard deviation how to measure moving range, average moving range. This one is a indicates statistically average. So average moving range divided by, already I told the D constant. This constant value is a 1.28. This is the constant value, right? So standard deviation you can easily calculate. Moving average range, this 5.35 divided by 1.128, right? And n is a number of population. That means number of sample you collected, right? So you easily calculate upper control limit. This one I am only giving the next slide. How to upper control limit measure is average x bar plus 3 sigma, and lower means average value minus 3 sigma, right? In such a way, upper control limit you can calculate, and by this formula you can easily measure the lower control limit. And upper specification and lower specification already you know, as per the pharmacopoeia monograph, 475 to 525 already everybody will know. So in such a way we calculate uh, UCL, LCL, 3 sigma, and 3 sigma, 3 into sigma already standard deviation calculated, and in such a way 3 sigma already 3 into 4.74, this one. Now we put this data in the control chart. See, this is the control chart. This red line shows the this on the upper control limit, this on the lower control limit, right? And this green line indicates the upper specification limit and lower specification limit. Already I told before you, that's all data in the typical control chart. All data should be, all control data should be within the specification limit. That's called the typical control chart. That means your quality is the fantastic in the robust process. Okay. So the following points are plotted versus either serial number of the batch number, the observation control lines, average value, target point, and specification. Clear? This is the typical ideal control chart. And by applying the before method, you can easily calculate upper control limit, lower control limit, average line, standard deviation, 3 sigma, everything. Another chart, addition parameter. So already I told that your process is stable. Now your process is capable, whether your process is capable or not. So to understand the process capability, another two parameters, process capability index, that already I told before the first slide, process capability ratio, CP ratio. There are two parameters already, CP ratio and CPM. This is the ratio and this is the value. Mathematically, already told. Mathematically, CP ratio can be calculated difference the specification limit divided by the control limits. Clear? And clearly, the CP value 1.3 or more is always the designated. And by this calculation, we can measure through control chart what's your CP ratio in your process quality. Clear? Next slide. Just I am showing the three criteria. When the CP ratio less than 1, this indicates the condition, under the condition CP ratio less than 1. Here non-conformity is invariable. See, this can be minimized by setting the process at the mid specification. So CP ratio 0.4 here. Here this control chart indicates CP ratio by mathematical expression calculated 0.34. Already I told before in your first slide, the tables showing the higher the CP ratio, higher the CP ratio, higher will be the quality. Lower will the CP ratio, lower will be the quality. That means the defectives per million will be the raised by lowering the CP ratio. Already I told, already I showing before slide. Now the condition, another condition is CP ratio 1. When the CP ratio is 1, the process is just capable, barely capable. So many Indian pharmaceutical company under this condition maintain this condition CP ratio 1, right? In this condition, most of the Indian pharmaceutical company maintain. Just their process is barely capable. That's called the 3C. Next, under the condition CP ratio greater than 1, the process is highly capable. Highly capable. Highly capable means your product output within your specification is just synchronized. That means your average line, target line just synchronized. That means your quality is the highly robust. That means you can assure your quality is the best other than the company. So our target as an Indian pharmacist, we as a pharmacist, our challenging our target to reach CP ratio greater than 1. That's called the CC. CPM. This is the value. PC ratio, CP ratio is the ratio, and CPM is the value. It takes account the division is the also can be expressed by the mathematical expression. This is a very interesting calculations. See, but it's showing very complicated. But when you understand the mechanism, it's very easy. So CPM value is the difference of specification divided by 6 into square root this one. So already everything you know, average value, target, sigma, already you know the specification limit. You can easily calculate by this formula. Okay. So in by applying this formula, you can easily CP desirable value of the CP at least 1.3. So if you maintain at least in the Indian soil in your pharmaceutical quality the CP ratio 1.3 or 1.33, all regulatory guidelines, domestic regulatory guidelines easily give the licensing authority and the process is robust. But international guidelines, they do not agree. They already want from the Indian pharmaceutical company the CP ratio at least 1.6 or 1.8 to reach. That's why international guidelines, ICH or USFDA or WHO guidelines is more stringent than our domestic guidelines. Understood? Here is another example for folic acid. This is also one finished products. Here, see, CPM you can calculate 0.46, 0.45, indicating the average has shifted from the target. See, here the CP value, CPM below the 1. That means your average value gradually disperse or shifting from the target. That means your quality is not robust. Anytime your quality fail, anytime. Next, and this is the total tables. How you maintain in the pharmaceutical industry practically. I am showing such slide that slides never showing in any statistical books. If you maintain this type, statistics already told us